Hey guys, so this is my second attempt of becoming a YouTube star. So I hope you enjoyed last video and um, yeah. So as you see, we've been working on changing momentum and we did the 1D and 2D situation. So you've learned it last year actually. It used to be in the year 12 curriculum, but we changed it. They've changed the things into year 13 curriculum, but we still taught it in year 12. So you guys get a feel of how it works, because vector was taught at year 12, and that was quite an important thing in terms of analyzing projectile motion, force, circular motion, and a lot of other things. And as obviously, like this year is quite important as well. So, and in fact, it's more important than last year. So yeah. Anyway, so today we're gonna be working on change of momentum. So you've seen the notes, and hopefully you've copied it down, and you've done this last year as well. Some of you guys have done really great, and so you were saying, "Oh, we're just repeating what we've learned last year." So, yep, that's exactly what's going on right now. So, if you struggle a little bit, so spend a bit more time and try to get some help on this part. So, you didn't get tested last year, but this year you will be tested on this. So, most of the time, it's just like one question on either conservation of momentum or change of momentum, because we got simple harmonic motion and rotational motion, and those are like almost like more important, and that's like more difficult. Okay, all right, so without further ado, so let's have a quick look. So last time we say the momentum is going to stay conserved if there is no like external force. So but if there is an external force, and then the momentum will change. So I give you the equation. So the change of momentum will equals to this new idea, old idea from last year. So we invented called impulse. Okay, what is impulse? Impulse is just force times time, and obviously impulse has a direction as well. So I should have put an arrow on the top of impulse. So I'll add that onto the note, because the force have a direction. Because if force have a direction, change impulse will have a direction. So they're same direction. Okay, and then when I tell you. So you don't need to remember the equation, but I always teach my students like to remember the equation, or to at least understand it. If you understand it, you can remember it, and that helps you basically that helps you to work on the questions and have a like deeper understanding of these concepts. Okay, all right. See, so change of momentum equals to mass times the change of velocity, and the change of velocity equals to the acceleration times time. So now we can put acceleration with mass, and mass times acceleration is force. So that's why now it becomes force times time. This is the reason why change in momentum not only has something to do with force, it also has something to do with how long this force is acting. So momentum equals to F times T. And one other thing I want to remember here is you see like how when we talk about SI units are very important. Is we always use SI units because all these things can transfer from each other, right? So for example, like energy, we use joule. So when we use joule, the mass, we have to use kg, and we have to use meter per second. And this is the reason why, because all these equations are actually like linked together. Okay, and then at the bottom over here, we have a look of this example. So a typical example I've done last year as well. So if a few of you guys might be in my class, so a ball is going in to the right, and then there is a wall or a bat that's hitting the ball. So now you got a change of direction. So then we know this situation we're going to be used changing of momentum, because momentum is not conserved anymore. So, and then especially you see like it's asking you about this calculating the force. So we're going to think about how does force changing the velocity and changing the so we got two ways of doing it. So one way is we could be using like say force causing acceleration, and that's changing the velocity, right? So but that's year 11 and year 12 stuff. So this year we're using the other method, which is using the other method you can still calculate it. Like honestly, like give it a go. Once you finish you use calculating acceleration and using acceleration times mass to get force, you will get the same answer as you see from the equation I've derived before. This all linked together, okay? So, but in this particular one, we're going to use change of momentum, and then, so how do we calculate change of momentum? Change of momentum, first we have to remember the equation. It's final momentum minus initial momentum. And the change of anything is final minus initial. We've done change of velocity last year. It's final velocity minus initial velocity. Okay, and then I calculate the number, and I even draw a direction, like what direction they're going. So the later part is now I can't put the numbers in there, say 15 minus 25. The reason why is because this is a vector and quantity, and the direction really matters. So I have to put the direction into it. How do I put direction into it? Is I have to draw the vector diagram, and it's very important. And the vector diagram we draw need to based on the equation we have, which is what I emphasized on the last lesson as well. So, and now we have. We want to know delta P, so we started with PF. So what is the direction PF? PF is going downwards. So I'm going to use this. PF is going downwards, okay? And then we're going to say, okay, so it's minus PI. So PI is going to the right, so minus PI, and I need to go to the left. So I go like this, okay? And then this is PF minus PI. Okay, PF minus PI, and then what do I get? I get originally it was here, and then PF minus PI, now I got here. So this is going to be the change of momentum, went from here to here. So that's why delta P is going like downwards to the left bottom corner. And yeah, and once I have the vector diagram, again, once I got the vector diagram, I don't need my equation anymore, because the equation is to give me the vector diagram. And once I have the vector diagram, I've got to use the trigonometry to calculate my answers for delta P. So I've done that, then I get the answer, which is 29.2. And once I got that, I just need to divide that by time. I will be able to find my force, 146. Okay, so you can see this one is not too difficult. And yeah, so just give you guys another lesson to practice some questions on this part and the part before. So these vector diagrams, as it can be a bit confusing. So if you have any questions, and send me a message. So and also I would like to get some feedback from you guys. So if you have any questions, so say from your homework you've tried and say, oh yeah, this question 3, I don't know how to do. So that's what I do in class. I give the students, like say, I talk for half an hour, and then another half an hour I just give the time to students to work on the questions. And then if you see, say, hey, like this question I actually don't know what to do, so take a picture of it and send it to me, and then I will make a video about it and explain it to you. And if you are struggling with this question, so it's likely like other people might struggle with it as well. So I recommend you to just send me a message, or email me, or put it on Google Classroom, so that I can answer those questions for you. And hopefully I'll be able to grab I can't come to school, so hopefully someone will deliver me. I've requested someone to I request someone to deliver me the booklets. So, and then if that sends over, and then I can use it. Okay, so one last important thing is, I don't know when this is happening, is we got this textbook. So I highly recommend this textbook. In fact, I'm like quite pissed off. Like in our school, like we cannot require the students to buy this. Okay. Like if I could have my way, I would be like, well, everybody needs to buy this textbook because it's so good. It got all the notes and it got the questions. And the best thing about these questions is these questions are always break down to little steps. So say sometimes if you just see a big question, you don't know how to answer them, but they are breaking down. And then at the end, there are detailed answers, and there are notes here in the front, and then there are revision notes on the back as well that you can use. So this is like really fantastic. So, and I've had a lot of success with using this textbook with others, with the previous year students. So if that is you feel like, okay, I'm willing to invest another like $20 to buy this book, I would highly recommend you to do so. If you're doing this book, I mean, you don't even need to do the booklet that we give you. I'm happy for that. Okay, so you can just do this book. Or if you say, I don't want to spend the money, or like, I think it's good enough just to use the booklet that it's actually written by the same person, Pauline Bendel. Mrs. Bendel used to be head of physics here at Eggs, and she wrote this textbook, and she also wrote that booklet. Actually, this textbook comes from that booklet, but I think it has been it's a little bit better than the booklet that we have. So anyway, so we might order it together as a school, or if anyone tells you, or Mrs. Johnson in your email talking about it, so just be aware. So that could be happening, and So it might be a good idea to get that ordered through the school. If not, and I might organize it when I come back. So, but if you already have it or you want to buy it now, and you can, and that will help you. Okay. All right. So for your homework, just work on anything regarding to momentum, conservation momentum, change momentum, and don't work on center of mass yet because we haven't learned that yet. So the next lesson we will be talking about center of mass. Okay. All right. Thanks. So hopefully you guys enjoyed this lesson, and I'll see you in the next video.